Welcome to Mathematics 10 class. I am your teacher, Urzal Milet Tamundong. Before we begin, find a comfortable place. Have your pen and paper with you. Make sure you have your compendium of notes. Let us start. We will have a quick review first of our last lesson. Let us define chord, tangent, and secant. Chord. Chord is a segment that joins any 2 points on the circle. Take a look at the figure. We have circle O. What is the chord? Chord AB. Correct. Now let's move to tangent. Tangent is a line that intersects the circle at exactly 1 point. At circle O, the tangent line is tangent line AB, and the point of intersection of line AB and circle O is point P, which is called the point of tangency. Next is secant. Secant is a line that intersects a circle in 2 points. In the figure, we have circle C. Line AB is a secant, and their point of intersections are points A and B. Now, you are ready for our next lesson, which is Power Theorem. First theorem under Power Theorem is two-chord theorem. When two chords intersect inside a circle, each chord is divided into two segments. These segments are called chord segments. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. In the figure, we have circle O. Identify the two chords. Very good. The two chords are I, K, and H, J. So, we will have the equation AI multiplied to AK equals HA multiplied to AJ. Next is two-secant power theorem. A secant segment is a segment of a secant line that has exactly one endpoint on the circle. A secant segment that lies in the exterior of the circle is called an exterior secant segment. A special relationship exists between secants and external secant segments. If two secants intersect in the exterior of a circle, then the product of the measures of one secant segment and its external segment is equal to the product of the measure of the other secant and its external secant segment. Take note that the secants should intersect in the exterior or outside of a circle. So in the given circle A, identify first the two secants. If you identified secants P, M, and PO, then you are correct. And how about the external secant segment? So the external secant segments are PL and PN. Okay, again, the external secant segments are the parts of the secant that is outside the circle. So the equation will be PM, which is the secant, multiplied to PL, its external secant segment, equals PO, secant, times PN, its external secant segment. Lastly, the secant tangent power theorem. A tangent secant, I, a tangent segment is both the exterior and whole segment because it is the segment of the tangent with one endpoint on the circle. If a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. What is the name of the circle in the figure? Circle A. Good. And the second is PO. How about the tangent? PM. Great. What about the external secant segment? PN. Good job. So the equation now is PM squared is equal to PO, the second, multiplied to PN, its external secant segment. To understand more the different power theorems, let us now proceed to our illustrative examples. Example number 1. Observe the figure. What parts of the circle are given? Correct. We have two chords. Chord number 1 and chord number 2. Therefore, we will use two-chord power theorem. Our equation now will be 7 times 4 equals x times 6. Multiplying 7 times 4 is 28 equals x times 6, that is 6x. Then dividing both sides by 6, the value of x now is 14 over 3. Did you get it? Very good. But if you don't, we still have many examples ahead. Let us now proceed to example number 2. What do you observe? Very good. We have two seconds. Second 1, second 2. So we will use two-secant power theorem. Our equation now is secant, so 2 plus 10, we have 12, multiplied to its external secant segment, which is 2, equals secant, that is x plus 5, multiplied to its external secant segment, which is x. Now let's simplify. 12 times 2 is 24. Then distribute x. X times x is x squared. X times 5, that is 5x. Okay, subtracting both sides by 24, we now have 0 is equal to x squared plus 5x minus 24. Next, we will factor this quadratic equation. Again, our equation will be x squared plus 5x minus 24 equals 0. Factoring out, we have the quantity of x minus 3 multiplied to the quantity of x plus 8 equals 0. So the factors are x equals 3 or x equals negative 8. The final answer will be x equals 3. We cannot use x equals negative 8 because we cannot have negative value. Did you get it? Very good. Let us now proceed to example number 3. Again, observe the figure. What do we have? Very good. We have a tangent and a secant. So we will use the secant tangent power theorem. Our equation now will be the square of the tangent, so that is x squared, equals secant, so 9 plus 16, that is 25, multiplied to its external secant segment, which is 9. So our working equation is x squared equals 9 times 25. So x squared is equal to 9 times 25, 225. Extracting both the squares, we have x is equal to the positive and negative 15. So the final answer is x is equal to 15. Again, we will only take the positive value. Did you get it? Very good. Example number 4. What do we have? Very good. We have a secant and a tangent. So we will use what power theorem? Okay, secant tangent power theorem. What will be the equation? Very good. So let's square first the tangent. So that is 18 squared equals the secant, which is x plus 10, multiplied to its external secant segment, which is 10. Okay, 18 squared is 324 equals, distribute 10, 10 times x, that is 10x, plus 10 times 10, that is 100. Subtracting both sides by 100, we will now have 224 equals 10x. Then divide both sides by 10. The answer is 22.4 equals x. For our last example, what power theorem we will use? We will use 2-secant power theorem. And our working equation is secant, that is x plus 8, multiplied to its external secant segment, which is 8, equals 20 plus 12, the secant, multiplied to its external secant segment, which is 12. Simplifying, distribute 8. 8 times x, 8x, 8 times 8, that is 64, equals 20 plus 12, 32 times 12. Simplifying further, 8x plus 64 equals 32 times 12, that is 384. Then subtract both sides by 64. we have 8x is equal to 320. Lastly, divide both sides by 8. Our final answer now is x is equal to 40. Did you get it? Very good. Now, before you have your activity, let's have some recap first. Again, under power theorem, we have two-chord theorem, two-secant theorem, and tangent secant theorem. For your activity number 9, page 10, find the length of the unknown segment x in each of the following figures. Answer the questions that follow. So you will write your answers on your intermediate pad and you will pass it during the retrieval of modules. So thank you for listening. Stay safe and God bless.